Tonight, we are going to attempt the impossible. We are going to try to force the human brain to comprehend something it was never designed to understand. We are going to explore a concept that you have heard 1,000 times in science fiction movies and astronomy documentaries. A phrase so common that it has lost its edge, its terror, and its majesty. The light year. But I promise you, what you think you know is merely the surface. When you truly peel back the layers of this measurement, when you stare into the abyss of the distance it represents, it does not just educate you, it fundamentally alters how you perceive your own existence. It changes the way you look at the night sky forever. It is not just a large number written on a page. It is a distance so aggressive, so violently vast, that it challenges the very architecture of our logic. By the end of this journey, you will understand why astronomers had no choice but to invent this unit. Because in the face of the cosmos, our earthly measurements crumble into dust. Before we engage our engines and leave the comfort of logic behind, if you crave these deep dives into the fabric of reality, make sure to ignite the subscribe button and ring the bell. It is a small click for you, but it fuels our ability to travel further into the unknown together. Leave a like if you are ready to have your mind bent. Now, let us begin on solid ground. Let us start with what your brain can touch. Distance. You understand distance intimately. You know the fatigue of walking to the grocery store. You know the rhythm of driving to your workplace. You understand the span of a city. These are human distances. They are measured in sweat, in footsteps, in the ticking of a wristwatch. A kilometer is a tangible thing. It is roughly a 12-minute walk at a brisk pace. It fits inside your life. If I tell you a destination is 5 kilometers away, your brain instantly calculates the fuel, the time, and the effort. You can visualize the traffic lights you will pass. You can smell the air changing. It is concrete. It is safe. Even if we expand our horizon to driving between cities, say 200 kilometers, you still possess mastery over that distance. That is 2 hours of music, a cup of coffee, maybe a rest stop. We have evolved over millions of years to calculate these distances for survival, to find water, to hunt prey, to return to the cave before nightfall. But what happens when we push beyond the horizon of human intuition? What happens when the numbers become so large they stop being measurements and start becoming abstract monsters? Let us fly from New York to Los Angeles. That is roughly 4,500 kilometers. It is a 5-hour flight across a continent. You watch the landscape shift from the dense urban sprawl of the East Coast to the flat, endless plains of the Midwest, rising into the jagged teeth of the Rockies, and finally dissolving into the Pacific Ocean. It is a long journey, yes, but it is achievable. Millions of people do it. It is within the realm of human dominance. Expand that to the entire circumference of our planet at the equator, 40,075 kilometers. It is massive, yet we have conquered it. Magellan's crew sailed it in 3 years. A modern jet could do it in under 2 days. The Earth, for all its grandeur, is finite. It is a cage we have mapped. But now, we must leave the Earth. Look up at the moon. The distance to that pale, glowing orb is roughly 384,000 kilometers. This is the precise moment where our standard measurements begin to fail us. 384,000 kilometers is not a road trip. There are no gas stations. There are no landmarks. It is a void of pure, suffocating distance. The Apollo astronauts, strapped to the most powerful machines ever built by human hands, traveling at speeds that would tear a normal car apart, nearly 40,000 kilometers per hour, still took 3 agonizing days to cross that gap. 3 days of floating in nothingness. And the moon is our backyard. It is so close we can see its craters with binoculars. It feels like we could reach out and touch it. Yet, that gap is a chasm that swallows our fastest technology, and if the moon breaks our sense of scale, the sun obliterates it. The distance to our star is 150 million kilometers. Try to visualize 150 million kilometers. You cannot. Your brain rejects it. It just files it away as a very big number. There is no evolutionary reason for a primate to understand 150 million of anything. At the speed of the Apollo spacecraft, that journey would take 160 days. 5 months of relentless travel through the dark. Even our fastest creation, the Parker Solar Probe, screaming through the void at 192 kilometers per second using the sun's own gravity as a slingshot, would still take months to cover that distance. And remember, the sun is right there. It warms your face. It lights your room. It is the definition of close in the universe. Yet, it sits across a gulf of 150 million kilometers. When we dare to look beyond the sun to the other stars, kilometers become not just useless, they become insulting. Using kilometers to measure the cosmos is like trying to measure the distance between continents using a microscope. The numbers become a meaningless, chaotic string of zeros. The next nearest star is 266,000 times farther away than the Sunday. We needed a new language. We needed a unit of measurement that wasn't based on human walking speed, but on the absolute speed limit of reality itself. Enter the light year. First, we must shatter a common misconception. Despite the word year, this is not a measure of time. It is a measure of distance. It is the distance that a photon of light, the fastest entity in existence, can tear through the vacuum of space in one single Earth year. Why light? Because light is the only constant in a chaotic universe. It is the cosmic speed limit. Nothing with mass can touch it. Light travels at approximately 300,000 kilometers per second. Let that sink in. 300,000 kilometers. Second. In the time it took you to blink just now, light could have circled the Earth's equator 7.5 times. Snap your fingers. In that instant, light could have flown from New York to Los Angeles and back 37 times. It is a speed so ferocious, it appears instantaneous to our biological eyes. When you flip a switch, the room floods with light instantly because the distance is negligible. But make no mistake, light takes time to travel. When you look at the sun, you are not seeing the sun as it is now. You are seeing a ghost of the sun from 8 minutes and 20 seconds ago. If the sun were to vanish this very second, we would remain blissfully ignorant, bathed in its warm glow for over 8 minutes, orbiting a nothingness that we cannot yet see. We are trapped in the past. When astronauts stood on the lunar surface, their voices took 1.3 seconds to reach Houston. Light, for all its godlike speed, is not infinite, it is finite. And that finiteness is the key to unlocking the true scale of the universe. So, let us do the math that breaks the brain. A light year is 300,000 kilometers per second, multiplied by 60 seconds, by 60 minutes, by 24 hours, by 365 days. The result is a number that screams at our comprehension. 9.46 trillion kilometers. 1 light year. 9.46 trillion kilometers. That is the measuring stick we must use. But do you really understand what a trillion is? We throw that word around in economics and politics like it's nothing. Let me give you a perspective that will haunt you. 1,000,000 seconds is about 11.5 days. You can survive that. 1,000,000,000 seconds is 32 years. That is a significant chunk of a human life. But 1,000,000,000 seconds? 1,000,000,000 seconds ago, there was no internet, there was no America, there was no Rome, there was no Egypt. 1,000,000,000 seconds is 31,700 years. If you started counting one number per second, right now, to reach 1 trillion, you wouldn't finish until the glaciers have returned and retreated again. You would have to start counting back when humans were painting in caves and hunting mammoths with sharpened sticks to finish today. That is 1 trillion. And a light year is almost 10 of those. 9.46 trillion kilometers. This is the unit we use for the closest things in our galaxy. To truly grasp the monster that is a light year, we cannot simply look at the final number. We must build it, brick by brick, second by second. We must walk the path of light to feel the horrifying scale of the void. Let us start small. Let us start with 1 light second, 300,000 kilometers. In the blink of an eye, Light travels a distance that is roughly equivalent to a round trip from Earth to the Moon, and then 3/4 of the way back again. Think about the implications of this. When Neil Armstrong and Buzz Aldrin stood on the lunar dust, looking back at the blue marble of Earth, they were not truly live. There was a ghost in the machine, a delay. When Mission Control in Houston spoke, their radio waves traveling at the absolute speed limit of the universe took 1.3 seconds to cross the black ocean between worlds. The astronauts would hear the question 1.3 seconds after it was asked. They would speak their reply, and that voice would take another 1.3 seconds to return. Every conversation had a built-in silence of nearly 3 seconds. A pause, not of hesitation, but of distance. In the recordings, you can hear it, a subtle, eerie lag that reminds us that even at our closest celestial neighbor, we are already drifting out of sync with time itself. Now, expand the scale. 1 light minute, 60 light seconds, 18 million kilometers. This brings us to the realm of the Sunday. Our star is 8 light minutes away, 150 million kilometers. This creates a terrifying reality. We have never seen the sun as it is now. We only see the sun as it was. If the sun were to suddenly go supernova right now, exploding with the force of 1 billion nuclear warheads, we would not know. We would go about our day. We would finish our coffee. We would walk the dog. For 8 minutes and 20 seconds, we would live in a blissful ignorance, orbiting a corpse, warmed by a ghost, until the wave of destruction finally crossed the gap at light speed to erase us. This delay turns space exploration into a nightmare of patience. Take Mars, the red planet. At its closest, it is about 3 light minutes away. At its farthest, over 20. When NASA engineers drive a rover like Perseverance on the Martian surface, they are not driving a remote-controlled car. They are driving a vehicle in the past. If the rover slips toward a cliff edge, and the camera sends a panic signal to Earth, that signal takes anywhere from 3 to 22 minutes to arrive. By the time the engineer in California sees the danger and screams, "Stop!" the rover has already fallen. The command to stop takes another 20 minutes to return. This is why we cannot explore the universe in real time. The speed of light is a prison that locks us into a delay we cannot escape. Let's go further. 1 light hour. 60 light minutes. Over 1 billion kilometers. We are now in the deep, cold dark of the outer solar system. Saturn, the jewel of our system, sits about 1.2 light hours away at its closest. When the Cassini spacecraft was dancing through Saturn's rings, capturing images of unearthly beauty, it was entirely alone. Every picture it took required over an hour to reach us. Every command we sent took an hour to reach it. The spacecraft had to be autonomous, smart enough to save itself, because if trouble struck, Earth was too far away to help. Mission Control was just a voice from the past, shouting into the void, hoping the machine was still listening. But even Saturn is just the front porch. Let's push to 1 light day, 24 light hours, roughly 26 billion kilometers. We are now entering a realm where humanity has barely scratched the surface. Voyager 1, the most distant object ever built by human hands, a machine launched in 1977, has been screaming through the void for nearly 50 years. It is moving at 17 kilometers per second, fast enough to cross the United States in minutes. And yet, after half a century of relentless travel, Voyager 1 is only just now about 1 light day away from Earth. Think about that. 50 years of human effort, 50 years of speed, to cover the distance light travels in a single day. Voyager is now in the interstellar medium, the space between stars. It is so far away that the sun is no longer a blinding disk of heat. It is just a piercingly bright star in a sea of darkness. The radio signals from Voyager, carrying its final whispers of data, take a full day to reach our giant antennas. We send a command, and we must wait 2 full days, 48 hours, to know if the spacecraft even heard us. It is the ultimate isolation. And yet, we are still nowhere near a light year. Let's accelerate. 1 light week is 181 billion kilometers. Out here, there is nothing man-made. The sun is just a point of light, barely distinguishable from the others to the naked human eye. You are in the abyss. One light month is nearly 800 billion kilometers. The entire solar system, everything we have ever mapped, everything we have ever named Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, the Kuiper Belt, all of it is now compressed into a tiny, insignificant dot of light in the rearview mirror. And finally, we arrive at the monster. 1 light year, 365 light days, 8,760 light hours, 31 million light seconds, 9.46 trillion kilometers. We started with a light second, the distance to the moon, and we multiplied it by 60, and 60 again, and 24, and 365. The scale is logarithmic in its terror. A light year is not just a distance, it is a wall. It is a barrier so vast that it separates civilizations. It separates cause from effect. It separates the past from the future. And here is the punchline that should keep you awake at night. The stars are not measured in kilometers. They are not measured in light days. They are measured in light years. The nearest star to us, our next-door neighbor, is not 1 light year away. It is over 4 light years away. Why do astronomers use this unit? Because if they didn't, they would drown in zeros. Telling you that Proxima Centauri is 40 trillion kilometers away is meaningless noise. Telling you it is 4.24 light years away tells you a story. It tells you that even if you could become a being of pure energy, riding a beam of light, it would still take you over 4 years of non-stop travel just to knock on your neighbor's door. It connects distance to time. It tells you that when you look at that star, you are seeing it as it was 4 years ago. You are looking into history, but the speed of light is not just a ruler. It is a law. It is the cosmic speed limit. Einstein taught us this, and the universe has confirmed it with brutal indifference. Nothing with mass can ever reach the speed of light. As you approach it, your mass increases towards infinity, and the energy required to push you faster becomes infinite. The universe forbids it. This means the light year is not just a measurement. It is a cage. It suggests that the stars might be visible, but they may forever be untouchable. So, let's talk about that neighbor. Let's talk about Proxima Centauri. Because understanding the gap between us and the closest thing out there is the only way to truly understand how trapped we really are. So, we are trapped. But how big is the prison cell? Let's look at the wall. Let's look at Proxima Centauri. In the vast theater of the cosmos, Proxima is our next-door neighbor. It is the closest star to the Sunday. If the universe were a crowded city, Proxima would be the house right across the street. But in space, across the street, is a distance that mocks human ambition. Proxima Centauri is a small, dim, red dwarf star, sitting in the darkness roughly 4.24 light-years away. It is part of the Alpha Centauri system, a triple threat of stars dancing in gravity's embrace. 2 of them are like our sun, bright and proud. But Proxima is the shy one, the faint ember glowing in the dark, invisible to the naked eye. You cannot see your closest neighbor without a telescope. That is how vast the emptiness is. 4.24 light years. It sounds small. 4 is a small number. You can count to 4 on one hand, but translate that back into kilometers, and the nightmare returns. 40 trillion, 140 billion kilometers. Let's try to cross that street. Let's take the fastest machine our species has ever built, the Parker Solar Probe. This is the pinnacle of human engineering, a machine designed to touch the Sunday, using the immense gravity of our star as a slingshot. It screams through space at a mind-bending 192 kilometers per second. That is nearly 700,000 kilometers per hour. At that speed, you could fly from New York to Tokyo in under a minute. It is speed that shreds our understanding of motion. Now, imagine we point that probe at Proxima Centauri and say, go. Maintain top speed. Don't stop. Don't slow down. Just fly. How long until we arrive? A month? No. A year? Not even close. A lifetime? Keep guessing. If you traveled at the fastest speed humanity has ever achieved, it would take you 6,800 years to reach the nearest star. Let me contextualize that horror for you. 6,800 years is longer than recorded human history. If you had launched this mission when the ancient Sumerians were scratching the first written words onto clay tablets in Mesopotamia 5,000 years ago, you would still be traveling today. You would have missed the building of the pyramids. You would have missed the rise and fall of Rome. You would have missed the life of Jesus, the Crusades, the discovery of the Americas, the Industrial Revolution, 2 world wars, and the invention of the Internet. While humanity was fighting, loving, dying, and building civilizations, you would have been floating in the silent void, barely closer to your destination, and you would still have nearly 2,000 years to go. This is the crushing reality of the light year. It turns our greatest technological triumphs into jokes. It reveals that we are not explorers of the galaxy. We are barely toddlers learning to crawl in our own crib. But wait, the optimists say, what about future technology? What about lasers? What about breakthrough starshot? Yes, let's talk about the dream of breakthrough starshot. It is a brilliant, audacious plan proposed by visionaries like Stephen Hawking. The idea is to build spacecraft the size of computer chips weighing just a gram, attach them to light sails made of materials thinner than a soap bubble, and blast them with the most powerful lasers ever built on Earth. The energy from the lasers would push these tiny ships to 20% the speed of light, 60,000 kilometers per second. Now we are talking. At that speed, we could reach Proxima Centauri in just 20 years. A single generation. A human lifetime. It sounds perfect. It sounds like hope. But physics is a cruel mistress. Even if we solve the impossible engineering challenges building lasers with the power of 100 nuclear power plants, aiming them precisely across millions of kilometers, ensuring the sail doesn't vaporize instantly, we face a new problem. Survival. At 20% the speed of light, interstellar space is not empty. It is a minefield. A single grain of dust, floating innocently in the void, hitting your spacecraft at 60,000 kilometers per second, hits with the force of a bomb. There is no shielding a chip against that, and if you somehow survive the journey, if you dodge every bullet the universe fires at you, you arrive at Proxima Centauri, and then what? You cannot stop. To slow down from 20% light speed would require the same massive energy you use to speed up. But you left your lasers back on Earth. So, you don't visit the star, you scream past it. You have maybe a few hours, minutes, even to snap a few blurry photos before you shoot past the system and into the eternal blackness beyond, never to return. And then, you have to send the data back. Your tiny 1-gram transmitter has to shout across 4.24 light-years of noise. It's like trying to whisper across the Pacific Ocean during a hurricane and expecting someone in Tokyo to hear you. And even if we hear it, when do we hear it? The data travels at the speed of light. So, 20 years to get there, plus 4.24 years for the signal to return. That is a 24-year round trip. You launch a mission when your child is born, and you get the first picture back when they are graduating from university. That is the best case scenario. That is the optimistic dream. The reality remains. Light years are not just distances to be crossed. They are barriers of time. They are walls of silence. But it gets worse. Proxima is just one star. A tiny, red dot. When we look up at the night sky, we aren't looking at Proxima. We are looking at giants. We are looking at stars that are tens, hundreds, thousands of light years away. And here, the light year stops being a measurement of distance and starts becoming a time machine. When you look at the stars, you are not seeing the universe as it is. You are seeing a graveyard. You are seeing ghosts. And in the next part of our journey, we are going to explore why the sky you see every night is a lie. We are going to discover how looking deep into space is actually looking deep into the past. and why some of the stars you wish upon might have died centuries ago. Here is a truth that might make you dizzy. The night sky is a lie. When you stand under the stars, looking up at the glittering dome of the heavens, your brain tells you that you are seeing the universe as it is. You think you are looking at a map of the present, but you are not. You are looking at a history book. You are looking into a graveyard. Because light takes time to travel, distance and time are indistinguishable in the cosmos. To look out is to look back. The farther you look, the deeper into the past you peer. The light year is the ultimate time machine. Let's calibrate this time machine. Look at Sirius. It is the brightest star in our night sky. The dog star, piercing the darkness with a brilliant blue-white fire. It sits 8.6 light-years away. That means the light hitting your retina tonight did not leave Sirius today. It left 8.6 years ago. You are seeing a ghost of Sirius from the past. If you are a young student, you are seeing Sirius as it was when you were just starting school. If you are older, you are seeing it as it was nearly a decade ago. You are seeing a version of the star that is already gone. But 8.6 years is a blink. Let's jump to Vega. This bright star is about 25 light-years away. If you are 25 years old tonight, gazing up at Vega, you are sharing a profound moment with the cosmos. The light entering your eyes right now began its journey the very year you were born. While you were taking your first breath, learning to walk, going to school, falling in love, and growing into the person you are today, that light was silently screaming across the void, never stopping, just to reach you at this exact second. You are seeing the universe of your birth. But now, let's go deeper. Let's look at Polaris, the North Star, the guiding light for sailors and explorers for centuries. It sits roughly 445 light-years away. Think about that timeline. The light you see from Polaris tonight started its journey around the year 1580. When that light left the star, the United States did not exist. The English colonies hadn't even landed at Jamestown. William Shakespeare was still alive, dipping his quill into ink to write plays that the world hadn't yet heard, while empires rose and fell on Earth, while the Industrial Revolution turned the sky grey, while world wars reshaped maps, while we invented cars, planes, and the internet. That light was just traveling, silent, unchanging, and it arrives tonight, carrying an image of a star from the era of Shakespeare. We are navigating our modern lives by the light of the Renaissance. And then there is the monster, Betelgeuse. Look at the constellation Orion. Look at the bright, reddish star on his shoulder. That is Betelgeuse. It is a red supergiant, a dying titan so massive that if you placed it in the center of our solar system, it would swallow Mercury, Venus, Earth, Mars, and reach all the way to Jupiter. It is about 550 to 648 light-years away. Let's say 550 light-years. The light you see tonight left Betelgeuse in the 15th century. Before Columbus sailed to the Americas, before Da Vinci painted the Mona Lisa. It is ancient light, but here is where the light year becomes a horror story. Betelgeuse is dying. It is unstable. Astronomers know that soon in astronomical terms it will explode into a supernova. It will shine as bright as the full moon, visible even in the daylight. But here is the terrifying question. What if it has already exploded? It is entirely possible that Betelgeuse died 300 years ago. It might have detonated in the year 1700, tearing itself apart in a cataclysm of fire and radiation. But the news of that death, traveling at the speed of light, hasn't reached us yet. We are 550 light-years away. If it died in 1700, the light of the explosion won't reach us until the year 2250. So, when you look at Betelgeuse tonight, you might be wishing upon a corpse. You might be admiring a ghost. The star could be gone, erased from existence, leaving behind only a black hole or a neutron star, and yet we will continue to see it shine brightly in our sky for centuries to come. We are living in a time lag. We are disconnected from the reality of the universe by the barrier of light speed. And this is just our local neighborhood. Let's zoom out to the galactic center. The heart of our Milky Way galaxy is 26,000 light-years away. If you look toward the constellation Sagittarius tonight, you are facing the center. The light coming from those dense star clusters left 26,000 years ago. Do you know what humanity was doing 26,000 years ago? We were living in the Stone Age. We were hunter-gatherers. We lived in caves. We hunted mammoths with spears made of flint. There was no agriculture, no writing, no cities, no concept of nations. We were barely surviving the Ice Age. The light that arrives tonight started its journey when your ancestors were huddled around fires, painting animals on cave walls to make sense of their world. Civilization, everything we call human history, every king, every prophet, every invention, happened while that light was in transit. That light is older than civilization itself, and if we look across the galaxy, the Milky Way is 100,000 light-years across. If you were a being of pure light, it would take you 100,000 years to cross it. Our species, Homo sapiens, is only about 300,000 years old. That means to cross our own galaxy takes a third of the entire history of our species. If there is a civilization on the other side of the galaxy looking at Earth right now with a telescope powerful enough to see the surface, they don't see us. They don't see cities. They don't see the Great Wall of China. They don't see lights at night. They see early humans, or perhaps not even humans yet. They see a wild, green planet roaming with creatures that no longer exist. They are looking at Earth, but they are missing us entirely. We are alone in time, just as we are alone in space. The light year forces us to accept a profound isolation. It means that the universe is not a live broadcast. It is a series of delayed tapes, arriving out of order, from different eras of history. But if you think the galaxy is big, prepare yourself, because we are about to leave the Milky Way. We are about to step into the realm of the observable universe, where the numbers stop being history and start becoming eternity, where the expansion of space itself turns the light year from a measurement into a prison wall that is moving away from us faster than we can ever catch it. We have explored our neighborhood. We have explored our galaxy. But now, we must face the monster in its entirety. We must look at the observable universe. This is the limit of our reality. The observable universe is a sphere of existence centered on you. It is the region of space from which light has had enough time to reach us since the Big Bang, 13.8 billion years ago. But do not make the mistake of thinking the universe is 13.8 billion light-years wide. That would be too simple. That would be too logical. While that ancient light was traveling toward us, fighting its way across the void for billions of years, the universe was doing something terrifying. It was expanding. Space itself was stretching. The road was getting longer while the car was driving on it. Because of this relentless stretching, the edge of what we can see is not 13.8 billion light-years away. It is 46.5 billion light-years away in every direction. That gives us a stage that is 93 billion light-years across. Inside this colossal sphere, there are an estimated 2 trillion galaxies, not stars, galaxies. Each one a swirling island containing hundreds of billions of stars of its own. Do the math, and the numbers become a form of madness. There are roughly 200 billion trillion stars out there. That is a 2 followed by 23 zeros. There are more stars in the sky than there are grains of sand on every beach on Earth. And around those stars, planets. Trillions upon trillions of worlds. Worlds of ice. Worlds of fire. Worlds of diamond, and perhaps, worlds of life. The universe is not empty. It is crowded. It is teeming with potential. But just as you start to feel a sense of wonder at this abundance, physics steps in to deliver the crushing blow. The universe is not static. It is dying. Or rather, it is running away. Space is expanding, carrying galaxies with it, like raisins in a rising loaf of bread. But recently, we discovered something that chills the blood of every cosmologist. The expansion is not slowing down. It is accelerating. A mysterious force, which we call dark energy, is pushing the universe apart faster and faster every second. This creates a nightmare scenario known as the cosmic horizon. Imagine a galaxy located far away from us. As space expands, that galaxy moves away. The farther it is, the more space there is between us to expand, and the faster it recedes. At a certain distance, the recession speed becomes faster than the speed of light. Wait, you say. Nothing can travel faster than light. That is true for objects moving through space. But space itself? Space has no speed limit. Space can expand as fast as it wants. This means there are galaxies, entire civilizations, perhaps that are crossing a line right now. They are moving away from us faster than light can travel toward us. The light they emit today will scream into the void, trying to reach Earth, but the space in front of it will keep growing, stretching faster than the photon can fly. It is like running on a treadmill that is speeding up. Eventually, you are thrown off. That light will never reach us. Not in a billion years, not in a trillion years, never. These regions of the universe are being erased from our future. Every second that ticks by, thousands of stars pass beyond this cosmic horizon, disappearing from our causal reality forever. We are losing the universe. We are living in a time of privilege, where the sky is full of galaxies. But billions of years from now, as the expansion accelerates, those distant galaxies will fade away. They will be pushed beyond the horizon. Future astronomers, living on Earth billions of years from now, might look up and see nothing. Just the stars of our own galaxy, drifting in an endless, empty black void. They will have no way of knowing that the rest of the universe ever existed. The Big Bang, the expansion, the trillions of other worlds, all evidence will be wiped clean by the dark energy. They will think they are alone in a static, dark box. We are the lucky ones. We are the generation that can see the glory of the cosmos before it runs away. But this knowledge comes with a heavy price. The realization of our ultimate isolation. Even with warp drives, even with sci-fi technology, we could never reach those galaxies. They are physically disconnected from our destiny. We are trapped in a shrinking bubble of influence, while the rest of creation rushes away into oblivion. And if this large-scale isolation isn't terrifying enough, let's bring it back to something more personal. Let's talk about the silence. With all these stars, with all these 200 billion trillion possibilities, why is it so quiet? Why haven't we heard a whisper? This is the Fermi paradox. And the light year might be the villain here too. In the next part, we are going to explore why the universe's silence is the loudest scream of all. We are going to look at why alien civilizations might be screaming at us right now, but the light year ensures we will never, ever hear them. If the universe is so crowded, if there are trillions of worlds and billions of years for life to evolve, then we must ask the question that physicist Enrico Fermi famously screamed at the cosmos. Where is everybody? This is the Fermi paradox. The universe should be loud. It should be buzzing with the traffic of empires, the radio signals of trade, the energy signatures of megastructures. But when we point our radio telescopes at the stars, listening with the most sensitive ears humanity has ever grown, we hear nothing. Just the hiss of cosmic static. The universe is terrifyingly silent. Why? Are we the only ones? Are we the first? Or is there a darker reason? The light year offers a chilling answer. They might be screaming at us right now, but the distance is strangling their voices. Consider our own footprint. Humanity has been loud for about a century. Since the invention of radio and television, we have been leaking signals into space. Our news broadcasts, our wars, our sitcoms, our radar pings, they are all expanding outward from Earth in a sphere of electromagnetic noise, traveling at the speed of light. That sphere is now roughly 100 light-years in radius. That sounds impressive, right? A bubble of humanity stretching 100 light-years into the dark. But remember the scale. The Milky Way is 100,000 light-years across. If you look at a map of our galaxy, Our radio bubble is not even a pixel. It is a speck of dust in a cathedral. We have barely cleared our throat. We haven't even announced our presence to 1% of the galaxy. Unless an alien civilization is living right on top of us, within that tiny 100 light-year neighborhood, they have no idea we exist. To the rest of the galaxy, Earth is silent. Earth is just another rock. And the reverse is true. If there is a civilization 1,000 light-years away which is practically next door, in galactic terms, and they invented radio 900 years ago, their signals haven't reached us yet. We are separated by a wall of time. But let's assume the best-case scenario. Let's assume we do make contact. Let's assume tomorrow a signal arrives from a star just 50 light-years away. A greeting. A message of peace. This would be the greatest moment in human history. But the light-year immediately turns this dream into a logistical nightmare. You receive the message. Hello, you are excited. You rush to the transmitter to reply, hello, we are humans, we are here. Your message travels at the speed of light. It takes 50 years to reach them. By the time they hear your hello, 50 years have passed on their world. The alien who sent the original message might have retired or died, but let's say they are patient. They receive it, and they immediately reply, good to meet you. That reply takes another 50 years to return to Earth. Total round-trip time, 100 years. You, the person who discovered the signal, will be dead before the answer comes back. Your children might be old. Your grandchildren will be the ones to hear the response. This is not a conversation. This is archaeology. There can be no galactic internet. There can be no Skype calls with ET. There can be no trade negotiations, no treaties, no exchange of cultural trends. Every sentence takes a lifetime. Every question is a legacy passed down to the next generation to await the answer. It gets worse. What if the signal comes from 1,000 light-years away? You receive a message. It was sent when William the Conqueror was invading England in 1066. You reply. Your answer arrives in the year 3024. The civilization that sent the first message might have destroyed itself in a nuclear war 5 centuries ago. You are not talking to aliens. You are talking to ghosts. The light year ensures that any dialogue with the cosmos is a conversation between the dead and the unborn. It isolates every civilization in a bubble of causality. We might be surrounded by friends, but the distance is so great that we are effectively alone in a dark room, shouting messages that won't be heard until we are dust. And if communication is this hard, imagine physical travel. We dream of Star Trek. We dream of warp drives. But without magic physics, we are stuck with relativity. And relativity has one final, mind-bending trick up its sleeve. A trick that makes space travel possible for the traveler, but heartbreaking for those left behind. We are about to enter the realm of time dilation. In the next part, we are going to explore why, if you ever decide to travel to the stars, you can never come home again. We will see how traveling at light speed creates a paradox where you stay young, but everyone you love ages and dies. Let's say we solve the energy problem. Let's say we solve the shielding problem. Let's say humanity builds a ship that can cheat the void. We build an engine that pushes us to 99.9% the speed of light. At this speed, the light year stops being a barrier of time for you. Einstein's special relativity kicks in with full force. It's a concept called time dilation, and it is not science fiction. It is a measured, proven fact of our reality. The faster you move through space, the slower you move through time. If you are on that ship, watching the universe scream past your window at 99.9% light speed, the distance to the stars seems to shrink. A journey to a star 10 light-years away, which should take 10 years, might feel like it only takes a few weeks or months to you. You could travel to the edge of the galaxy within a human lifetime. You could be an explorer of the cosmos. But there is a catch. There is always a catch. Time slows down for you. But it does not slow down for Earth. The universe keeps ticking at its normal, relentless pace. Imagine you say goodbye to your family. You are 30 years old. You leave behind a spouse and a newborn baby girl. You board your ship, destination. A star 25 light-years away. You travel at 99.9% light speed. To you, the journey feels miraculous. You spend a year on the ship reading, exercising, preparing. You arrive at the star, spend a few months exploring strange new planets, taking samples, seeing things no human eye has ever seen. Then you turn around and fly home. Another year on the ship. From your perspective, you have been gone for maybe 2.5 to 3 years. You are now 33. You are excited to see your wife. You can't wait to hold your baby girl, who should be a toddler now, maybe learning to speak. But as you decelerate and enter Earth's orbit, silence greets you. The radio frequencies you used to know are dead or filled with strange new codes. You land, you step out, and you realize the horror. You traveled 25 light-years out and 25 light-years back. Regardless of how much time passed for you, the journey took 50 years for Earth. Your spouse is 80 years old, or perhaps they have been dead for a decade. Your baby girl is a 50-year-old woman with grandchildren of her own. She doesn't know you. To her, you are a ghost, a face in a photograph on the mantelpiece, a father who left before she could remember him. Your friends are gone. The world has moved on. Politics, technology, culture, everything has shifted half a century. You are young. You are healthy. You are a hero. But you are homeless in time. You have traveled to the future, but the cost of your ticket was everyone you ever loved. This is the twin paradox writ large. Space travel at relativistic speeds is effectively a one-way trip into the future. You can never go back to the time you left. Every light year you cross at high speed is a year of history you tear out of your life on Earth. Now, imagine going further. Imagine traveling to the Andromeda galaxy, 2.5 million light-years away. If you could travel close enough to the speed of light, say 99.9999999%, you could reach Andromeda in what feels like 50 years to you. You could survive the trip. You could see a whole new galaxy. But when you arrived, 2.5 million years would have passed on Earth. The human species might be extinct. The continents would have shifted. A new ice age might have come and gone. You would be an alien relic from a forgotten epoch. And if you turned around and came back, another 2.5 million years, you would return to an Earth 5 million years in the future. The sun would be hotter. The biology of the planet would be unrecognizable. You would be the last human, carrying the memories of a ghost species that died while you were eating lunch on your spaceship. This is the ultimate tragedy of the light year. It separates us not just by space, but by causality. It forces us to choose. Stay here and wither with your loved ones, or leave and live forever as a stranger. There is no middle ground. The universe demands a sacrifice for speed. This realization forces us to confront a humbling possibility. Maybe the reason we don't see galactic empires, maybe the reason nobody is visiting us, is because biological creatures simply cannot endure this separation. Maybe civilizations stay home because the heartbreak of leaving is too great. Or maybe they send machines. Cold, unfeeling machines that don't care about time, that don't mourn the parents they left behind. In the next part, we will descend from the high-speed tragedy to the slow, creeping reality of our own future. We are going to look at the collision course we are on right now. We don't need to travel to the stars to experience a cosmic catastrophe. One is coming to us. We are going to talk about the collision with Andromeda and the eventual, beautiful destruction of our night sky. You don't need to travel at the speed of light to witness the end of the world. You just have to wait. Because right now, at this very second, a monster is coming for us. Look at the constellation Andromeda tonight. If you have good eyes and a dark sky, you might see a faint, fuzzy smudge of light. That is the Andromeda galaxy. It is a spiral city of 1 trillion stars, twice the size of our own Milky Way. It sits 2.5 million light-years away. In the vast, expanding universe, almost all galaxies are rushing away from us. But Andromeda is different. It is rushing toward us. driven by the mutual pull of gravity. Our two galaxies are falling into each other at a speed of 110 kilometers per second. That is 400,000 kilometers per hour. But the distance the light year is so vast that this collision will play out in agonizingly slow motion. It is a car crash that takes 4 billion years to happen. But it will happen. It is mathematically inevitable. Let's fast forward the tape of history. Let's stand on Earth, or whatever is left of it, and watch the sky change. 2 billion years from now, Andromeda is no longer a smudge. It is a distinct, glowing disk in the night sky, growing larger every epoch. It rivals the Moon in size, a ghostly second galaxy hanging over our heads. 3.75 billion years from now, the show begins. Andromeda fills the entire field of view. Its spiral arms are stretched and warped by the gravity of the Milky Way. The night sky is no longer black. It is a tapestry of swirling light. The sheer gravitational tidal forces begin to tear the outer edges of both galaxies apart. 4 billion years from now. First contact. The two galaxies slam into each other. But this is not a collision of solid objects. Galaxies are mostly empty space. The stars within them, our sun included, are like grains of sand separated by kilometers of vacuum. So, incredibly, stars will almost never physically collide. They will pass right through each other like ghosts. But the gas is a different story. The massive clouds of hydrogen in both galaxies will crash together, compressing and igniting. The sky will burst into flames. Millions of new stars will be born simultaneously in a frenzy of creation known as a starburst. The night will be bright enough to read a book by, illuminated by the fires of newborn blue giants and the explosions of supernovas going off like firecrackers across the heavens. The fate of the sun. In this chaos, our solar system will likely be flung out of its quiet suburban orbit. We might be tossed into the deep, cold void of intergalactic space, exiled from the galaxy entirely. Or we might be hurled into the blazing, crowded core of the new supergalaxy. Either way, the Milky Way will die. Andromeda will die. Their spiral shapes will be destroyed, their elegance smashed. But from their corpses, a new titan will rise. Astronomers call it Milkomeda. It will be a giant elliptical galaxy, a massive ball of old, red stars, settling down into a quiet, eternal retirement. The chaos will end, the fireworks will fade, and the sky will return to black. But it will be a different sky. A sky without the band of the Milky Way that humans have looked up to for 200,000 years. This event forces us to realize that even the things we consider eternal, the stars, the galaxy structure, the constellation shapes, are temporary. They are just clouds shifting in the cosmic wind. The light years that separate us from Andromeda today are just a countdown timer. But there is a darker implication here. When Milkomeda forms, the universe will look very different to any intelligent life that evolves inside it. Remember the expansion of the universe? Remember how distant galaxies are disappearing beyond the cosmic horizon? Billions of years from now, all the other galaxies will have rushed away. They will be too far to see. Milkomeda will be the only thing left in the observable universe. Future astronomers born in this era will have no way of knowing that the universe is expanding. They will see a static, lonely island of stars surrounded by infinite, empty darkness. They will think they are the whole universe. They will construct theories of physics that are completely wrong. Because the evidence of the Big Bang, the receding galaxies, will be gone. The light year will no longer be a tool to measure the distance to other galaxies, because there will be no other galaxies to measure. We are living in a golden age of cosmology. We live in the brief window of time where we can see the truth of our origins and the truth of our future. We can see the collision coming. We can see the expansion happening. But this window is closing. So, we have seen the past through light. We have seen the future through gravity. But what about the now? What is happening right now at the heart of our own galaxy, in the darkest place of all, where light itself goes to die? We are about to enter the trap, the place where a light year becomes zero, the place where space and time switch roles. We are going into the black hole. We have talked about light speed as the ultimate ruler of the universe. We have said that nothing can break this limit. But what happens when the universe creates a monster so hungry, so heavy, that it turns light speed against itself? Deep in the heart of our galaxy, and in the hearts of almost every galaxy in the observable universe, lies a supermassive black hole. Ours is called Sagittarius A*. It has the mass of 4 million suns crushed into a space smaller than our solar system. A black hole is not a hole. It is a place where gravity has become infinite. It is a puncture in the fabric of reality. And it has a boundary, a line in the sand. We call it the event horizon. This is the most terrifying line in the universe. Outside this line, you can struggle. You can fire your rockets. You can try to escape. But the moment you cross it by even a millimeter, your destiny is sealed. Why? Because at the event horizon, the escape velocity required to break free exceeds the speed of light. Think about what that means. We established that nothing can travel faster than light. Not matter, not information, not a signal, not a scream. Therefore, if the speed required to leave is faster than the fastest thing in existence, then nothing leaves. Inside this boundary, all paths lead down. There is no left, no right, no up, no down. Every direction you look, every direction you move, leads to the center. It is geometric inevitability. Trying to avoid the center of a black hole once you are inside is like trying to avoid next Tuesday. It is not a place you go, it is a time you must experience. Inside a black hole, space and time switch roles. The center, the singularity, is no longer a location in space. It is a moment in your future. But let's imagine you are falling in. Let's experience the death of light. As you approach the event horizon, the universe begins to warp. The gravity is so intense that it bends light like a lens. You would see the back of your own head. You would see the entire sky behind you compressing into a smaller and smaller circle of light, like a closing eye. And then, there are the tidal forces. If you fall into a smaller, stellar mass black hole, you don't just die. You are unmade. The gravity at your feet is infinitely stronger than the gravity at your head. You are stretched. Your body is pulled into a long, thin noodle of flesh and bone. Astronomers have a technical term for this, and it is horrifyingly descriptive. Spaghettification. You are ripped apart, atom by atom, cell by cell, turned into a stream of subatomic particles flowing into the abyss. You are deleted from biology. But if you fall into a supermassive black hole, like the one in the movie Interstellar or the real M87 times galaxy, the tidal forces are gentler at the horizon. You might cross the line without even feeling it. You would be alive. You would be conscious. You would look back and see the universe you left behind. But no one can see you. To an observer watching you from a safe distance, something heartbreaking happens. They never see you fall in. As you get closer to the horizon, the light coming from your body has to fight harder and harder to climb out of the gravity well. It loses energy. It shifts to red. Time begins to slow down for you from their perspective. They see you move slower and slower and slower until, right at the edge, you freeze. You fade into a dim red ghost, hovering there for eternity, never crossing, never dying. You become a permanent image frozen on the edge of the dark, but from your perspective, you fall straight through. You cross the horizon in an instant. You look back, and the universe behind you seems to speed up. You might see the entire future history of the galaxy play out in a hyperlapse frenzy as you plunge toward the center. You are separated from reality. You are in a new universe now, a pocket of space-time that is cut off from the rest of creation. You could scream, shine a laser, explode a nuclear bomb, no signal will ever leave. You have become information paradox. Physics tells us that information cannot be destroyed. But if you fall in, where does your information go? Does it vanish? Is it stored on the surface? Or is it spat out billions of years later in the form of Hawking radiation? We don't know. The black hole is the place where our understanding of the universe breaks down. It is where relativity, the science of the big, and quantum mechanics, the science of the small, crash into each other and fail. It is the end of the map. And yet, black holes might be the creators of galaxies. Without their immense gravity anchoring the center, the Milky Way might not exist. The monster that eats light is also the shepherd that holds the stars together. We have traveled from the speed of a light beam to the crushing stillness of a singularity. We have seen the universe expand and contract. But there is one final perspective we must take, a perspective that brings all this cosmic terror back to something we can hold in our hands. We need to talk about you. In the final part of our journey, we are going to reverse the telescope. We are going to look at what being made of star stuff actually means. We are going to find the connection between the 9.46 trillion kilometers and the atoms in your right hand. We are going to conclude this epic not with fear, but with a profound, spiritual awakening about our place in the infinity. We have traveled to the edge of the visible. We have stared into the black abyss where time stops. We have felt the crushing weight of the light year, that ruler of isolation that separates us from our cosmic neighbors. It is easy to feel small. It is easy to look at the number 9.46 trillion kilometers and feel like a mistake, a microscopic accident on a grain of dust, floating in a hostile, empty void. But before we close this book, I need you to do one thing. Look at your hand. Turn it over. Look at the veins in your wrist. Look at the skin on your fingertips. Do you know what you are looking at? You are looking at a graveyard of stars. The hydrogen in the water of your cells? That was born in the Big Bang, 13.8 billion years ago. It is the oldest thing in existence. The carbon in your DNA, the calcium in your teeth, the iron in your blood that turns it red when you bleed. These atoms were not created on Earth. Earth cannot create them. They were forged in the nuclear furnaces of stars that lived and died billions of years before our sun was born. When a massive star like Betelgeuse explodes, it doesn't just die. It gives. It scatters its guts across the galaxy. It shoots carbon, oxygen, and iron into the void at millions of kilometers per hour. Those atoms drift through the interstellar dark for eons, crossing those terrible light years we talked about, until gravity pulls them together again. They form a nebula. They condense into a new star. They form planets. And on one of those planets, after 4 billion years of chaotic chemistry, those atoms stood up. They learned to walk. They learned to think. They learned to look back at the sky. You are that star. You are not in the universe. You are of the universe. You are the universe waking up. You are the mechanism by which the cosmos understands itself. Think about the improbability of this moment. For 13.8 billion years, the universe was blind. It was just energy and matter, expanding, cooling, clumping. But then, you opened your eyes. Through your eyes, the universe can see its own grandeur. Through your mind, it can calculate its own age. Through your heart, it can feel awe at its own beauty. Without you, without conscious observers, the light year is just a number. The collision of Andromeda is just silent violence. The black hole is just a math equation. It is you who gives it meaning. It is you who turns distance into wonder. So, yes, the distances are vast. Proxima Centauri is 4.24 light-years away. We may never visit it. We may be trapped on this rock by the speed of light, isolated from other civilizations by the walls of time. But we are not insignificant. We are the custodians of meaning. Perhaps we are the only ones. Perhaps, in this entire galaxy of 100,000 light-years, we are the only minds capable of looking up. If that is true, then we are not just biological accidents. We are precious. We are the candle flame in the cathedral. If we go out, the universe goes back to being blind. It goes back to the dark. This perspective changes everything. It means that taking care of this planet, taking care of each other, is not just a moral duty. It is a cosmic responsibility. We are the ark carrying the only thing that matters: consciousness. We have spent tonight talking about limits. the speed limit of light, the horizon limit of the universe, the lifespan limit of humanity. But there is one thing that has no limit: imagination. Our bodies are stuck on Earth, but our minds can travel to the edge of the observable universe. We can visualize the fall into a black hole. We can predict the death of the sun. We can map the cosmic web. The light year cannot stop our curiosity. So, the next time you walk outside at night, don't just look at the stars. Look with them. Feel the photons hitting your retina. Little packets of energy that have traveled for hundreds of years just to end their journey in your eye. Feel the connection. You are small, but you are mighty. You are temporary, but you are eternal. You are stardust, contemplating the stars, and that is the true scale of reality. Thank you for taking this journey with me. We have traveled from the humblest kilometer to the edge of infinity. We have broken our brains with numbers, and hopefully we have rebuilt them with a new sense of awe. If this video shifted something inside you, if it made the universe feel a little bigger and your place in it a little more special, then please consider joining our community of explorers. Click that subscribe button, not just to see more videos, but to signal that you are one of the curious ones. One of the people who isn't afraid to look into the dark and ask, why? Hit the like button if you want YouTube to share this cosmic perspective with others who need to wake up. And I have a question for you, a challenge, really. In the comments below, tell me, when you look up at the night sky now, knowing what you know about the time delay, about the ghosts of stars, do you feel more lonely or more connected? I read every single comment, and I want to know your story. Until next time, keep looking up. The universe is vast, but as long as we are looking at it together, we are never truly alone. Good night, star travelers.